So here we're not going to focus much on how they came up with the equation, but we will try and do the same thing that we did before. So let's see. This is the question. They're asking us to find something called the marginal rate of change. It's just a funny word for instantaneous rate of change. Yesterday we did it for polynomials. Today we'll be doing it for some other types of functions. You'll see that the answer is going to be, well, the process is the same. So here, instead of having a polynomial, we have a rational function. Rational function means you have something in the numerator, something in the denominator. 5x over 2 plus x. The question is simply asking you, what's the instantaneous rate of change when x is 1.5? So how do we do this? It doesn't matter what the function is, the process of finding IROC is the same. You remember from yesterday was the process of finding IROC. You're gonna go one level up and one level down, yeah?
Mm-hmm.
One level up and one level down. It just means plus 0.01 up and 0.01 down. So here, if it's asking you for x equals 1.5, again, this is not a polynomial function. Coming up with the shortcut is not that easy. You want to go one level up. So if you add 0.01 to this, what do you get?
1.51.
So this will be your b value, and you're going to subtract 0.01 from that. That'll give you 1.49, like that. All you do is f of b minus f of a all over b minus a. This method will work every single time. It doesn't matter if you have the shortcut or not. This will work 100% of the time for any function. Okay, this will work for any function. So here, this will become, if f of x is 5x over 2 plus x, what's f of 1.51? All you have to do is replace that x with 1.51. So you get 5 times 1.51 all over 2 plus 1.51. That is f of 1.51. And then now you take away 5 times 1.49 over 2 plus 1.49 all over 0.02. Your denominator, if you use this process, b minus a process, your denominator will always be 0.02 because 0.01 positive take away negative 0.01 will always be 0.02. So this will be a constant if you use this method. Now the only thing left to do is just plug this in a calculator and you will have your answer. 5 times that divided by 2 plus 1.51 minus 5 times that divided by 2 plus 1.49 divided by 0.02. The answer is negative 96. And you are done, okay?
Mm-hmm.
That is all you have to do. So what did we just find? If you want to graph this function, I don't know if you remember this, what value of x will give you a 0 in the denominator? What can x not
A
be?
-2.
-2. So that means you have a vertical asymptote at -2. At x equals -2, there's a vertical asymptote. And if you take the ratios, because this is a linear over a linear, if you take the ratio of the leading coefficient, which is 5 over a 1, that will give you your horizontal asymptote of 5. Now, when x is 1, you get a positive number. So I know that I'll be somewhere up here. So this is what the curve will look like. This is what this sketch will look like. And actually, no, because when x is 0, y will be 0. So even though it's a positive, it'll look like this on this side, and it'll look like this on the other side, okay?
Mm-hmm.
That's how you graph it. But all you have to do here is to have the formula. Just remember the formula. What about for this one? It's another rational function. They've given us an x value. What do we do?
You add and subtract 0.01.
Right, so you're gonna do f of, so the two numbers that you get is negative 4.99 and negative 5.01. Which one is B? Which one is A?
Negative 5.01 is B.
No, it's not, because it's smaller than negative 4.99. If you consider the number line, whichever number is to the right is the bigger number, right? So negative
Mm-hmm.
4.99, negative 4.99 is bigger than negative 5.01. Therefore, this is your B value. Whichever number is to the right on the number line is your B value. It's a little bit complicated, well, tricky when it's negative numbers. But here, all we're doing is f of negative 4.99 minus f of negative 5.01 all over 0.02. This will always be 0.02 if you're using plus minus 0.01. So now you just plug it into the calculator and you're done. So negative 4.99 divided by negative 4.99 plus 3 minus negative 5.01 all over negative 5.01 plus 3 divide by 0.02. The answer is 0.75, and that is the IROC, which is also called the slope of the tangent line. What about part B? Why can there not be a tangent line when x is equals to negative 3? What happens if x is negative 3 in that equation and f of x? Ooh,
It's 0.
you get a 0 in the denominator, more importantly, right here. If
Mm-hmm.
x were to be negative 3, you get a 0 in the denominator, which means the expression would be undefined. In other words, if you get a 0 in the denominator, you get a vertical asymptote. So here, if you were to go ahead and sketch this at negative 3, you get a vertical asymptote, and then you want to take the ratios of the leading coefficient. That'll give you a 1, because it's 1x over 1x. That is your horizontal asymptote at y equals to 1. When x is 0, 0 over 3, y is 0, so we have a point down here, which means this rational function is going to look like this. Okay?
Mm-hmm.
It always looks like this, or it could be the other way, like that. It's always going to be on the opposite side. If you're in doubt, you can always plug in an x value to see where the y value is. Like, for example, if you plug x as negative 4, you should get a y value that's bigger than 1, so you know you're up here. But if you're not sure, you can always double check. It's very rare that you're going to be down there, because if you were down there, if you write the asymptotes, you're going to get another x-intercept. But this thing only has one x-intercept at 0, which means that one's wrong. What did we just find? We found at negative 5, so somewhere here, we found the slope of this tangent line. Is that going to be positive or negative? Something that's going this way.
Positive.
Positive, and we do have a positive number here, so that's what we found. Cool.
Mm-hmm.
It's just plus minus 0.01. Let me show you the shortcut for this, which is way more complicated, but it is fun. Shortcut means the IROC function. Now you're gonna have to bear with me here. If you have, now I can't use f, can I? Let me use something else. Let's say you have some function j. This is in the form of some f divided by g, where f is the numerator and g is the denominator, basically a rational function. You can get j prime. J prime is the shortcut. J prime is going to be equals to f prime of g minus f g prime all over g squared. Now, what does all of this even mean? Let's go back to our equation. So we have x over x plus 3. Your f function is x. Your g function is x plus 3. Now remember, we did this yesterday. If f is x, what's f prime? What's the IROC function of x? Or 1x? It's a
It's
plural.
1.
It's 1. What about x plus 3? What's g prime? It's the same thing as 1x plus 3. The constant disappears, and you lose the letter. It's also 1, okay? Both f prime and g primes are 1. Now let's just plug into this equation here. So our function f prime of x will be equals to, again, I'm following this here, f prime, which is a 1, times g as it is, as it is x plus 3, minus f as it is, which is 1x or just x, times g prime, which is a 1, all over the original g, which is x plus 3, squared, like that. If you do this, you get x plus 3 minus x over x plus 3 squared. Now the x's cancel out. You get 3 over x plus 3 whole squared, okay? Like that. And that is your IROC function. That's the shortcut of doing this. If you don't want to do the plus minus 0.01, this is the formula if you have a rational function. Now, all we have to do to answer part A is to find f prime of -5. This right here is f prime, or the IROC function. We just have to replace this x with -5. So you get 3 over -5 plus 3 squared. You get 3 over 2 squared, or -2 whole squared. That's 3 over 4, that's 0.75. That's the exact same thing that we had when we did plus minus 0.01. Okay? So there exists a shortcut for almost every function. It's going to be hard to keep track of it. The easiest one is polynomial, but this is also kind of like a polynomial. You just have to use this formula, and I'll try and give this to you. You'll see this stuff in maybe grade, I don't know, 12. This one's a little bit complicated. I know they use the graphing calculator here, but we're not going to do that. Let's try and like think this through. I'm going to forget about the 50 for now. Look at this denominator. 25 plus t squared. Is there any value of t that would give you a 0 in the denominator? What about when t is -5?
But then it becomes positive.
Positive.
25.
So is there any value of t that will give you a 0 in the denominator? No,
No.
right? No, there's nothing that'll give you a 0 in the denominator. So that means this function does not have a vertical asymptote, okay?
Mm-hmm.
No vertical asymptote. The horizontal asymptote is the same idea. You take the ratio of the powers. So in the numerator, we have 2500 t squared. In the denominator, we have 1 t squared. You're going to get a vertical asymptote at y equals 2500, okay?
Mm-hmm.
Graphing this is not very simple, so we're going to just use a graphing calculator, which they've already done for us. Or maybe I'll use Desmos because I don't know what they're doing. I do know what they're doing, but the axis numbers are not that clear. That's what I mean. 50 plus 2500 x squared divided by 25 plus x squared. Now we know there's going to be a vertical asymptote, right? Somewhere at 2500. Did I do this right? Yeah. So you see at 2500, you see that horizontal line that's invisible? Like there's a, a dotted line here somewhere, okay? That's at
Mm-hmm.
2500. That's the horizontal asymptote. Now, if you look at this function, when is the slope of the tangent the steepest? Again, you have three options. Like at the end, like over here maybe, where it's almost horizontal, in the middle, or at the very beginning. What do you think? Where is it the steepest? Steep means the most vertical. If you draw the tangent lines, the most vertical. It's going to be in the beginning because the way this graph is shaped is like this, right? It goes like this, goes like this. So where is it the steepest? If you draw tangent lines, over here it's almost horizontal, so that's 0 at the end.
Mm-hmm.
It's going to be steepest at the beginning, right? So here what we have to find is and at the beginning the x value is 0, so we have to find p prime of 0. That's the answer. So let's do the same thing that we did last time. This is your function. P of t is 50 plus 2500 t squared over 25 plus t squared. P prime of t. You can forget the 50 because if you have a constant, it just disappears. This is your f, this is your g. So f is 2500 t squared and g is 25 plus t squared. What's f prime?
It's 5000 T.
Yes. What's g prime?
It's G.
Its g prime is going to be 2t. 25 plus t squared becomes 2t. Okay?
Mm-hmm.
And this is the formula. F prime g, it just alternates. F prime g plus f g prime all over g squared. F prime is 500t. G is 2t plus f as it is 2500 t squared. G as it is 25 plus t squared. All over g squared. So g is 25 plus t squared squared. There we go. This is p prime of t. And we're trying to find when the slope is the steepest. We know from the graph that it was at the very beginning. It was almost vertical. So we're going to find p prime of 0. Now look at this. 500 times 0 times 2t, or times 2 times 0, is a 0. So this entire thing disappears, right?
Mhm.
What about this expression? What does this evaluate to? This is a 0, so you can ignore it. This is a 0, so you can ignore it. Yeah?
Mhm.
This is a 0, so you can ignore it. So what are we left with? There's 3 numbers remaining, yeah?
Mhm.
Plug that in a calculator and you are done. That's it. This is called the quotient rule. This is basically the shortcut rule if you have a rational function. But you don't have to do it this way. You can always do 0 plus minus 0.01 and yeah, that. And whatever you get, so 0.01 and negative 0.01, you'd use the AROC formula and you will plug it in, okay?
Mhm.
That is all you have to do. Let's move away. It's exactly the same. If you know how to do one of these, you know how to do all of them. You can either use that formula I gave you, or you can just use plus minus 0 point whatever it was. Let's move on to trig functions. We're going to do the same thing for trig functions as well. You'll see not a whole lot changes. Okay, ignore that. Too many curves. Give us an equation. There we go. So they've given us an equation here. What's the function here? Is it a polynomial?
No.
No, it's not. What kind of a function is it? It's a trig function, right?
Mhm.
It is a trig function. So again, not a whole lot changes. So look at this. They've given us this. All you have to do is go 1 up. So d of 0.41. Go 1 down. So d of 0.39. And divide all of this by 0.02. That is all you have to do to find the IROC at t equals 0.4. This is one way of doing this. The only thing to be careful here is that on your calculator, because they've given you a pi is a radian measure, you have to be in radians, not in degrees. So 1.6 times cosine, I'm in degrees, so let me go to radians. 1.6 times cosine of pi times 0.41 divided by 0.8 plus 2.2. So this gives me 2.137. Take away 0.39. So 1.6 times cosine of 0.39 times pi divided by 0.8 plus 2.2. That gives me 2.2628 divided by 0.02. Now we basically have the answer divided by 0.02. It is negative 6.29 meters, because d is in meters. And on the run on the x-axis, we have seconds. So there we go, negative 6.29 meters per second. And that is a unit of speed. Remember, meters per second?
Mhm.
Unit of speed. So that's how you do it, basically. That is all you have to do. Cool?
Mhm.
What this means is on the curve at 0.39 or whatever it was, 0.4 is right here. You can see that the tangent is going down, it's decreasing. Now that is the calculator method of doing it. This always works. Plus minus 0.01 is always going to work for any function if you're trying to find IROC. Where things get a little bit complicated is when you're trying to use a shortcut. And this is a general rubric for a cosine function. If you have a times cosine k times t or whatever, k times x, if this is f, f prime will be the k comes outside. See that k comes outside? Multiply that with the number in the front, and cosine becomes negative sine. There you go. That's the formula for the shortcut. If you were to use that here, we're trying to find f prime of 0.4. What's our k value? Compare this with this. What's our k value? K is a number that's being multiplied by the t.
Pi over 0.8.
Right, so it'll be pi over 0.8 times, what's our a value?
1.6.
1.6 times negative, cosine becomes sine. Negative sine of k is still pi over 0.8, and our t value, our IROC value that we're interested in is 0.4. So now let's plug this into a calculator. So pi times 1.6 divided by 0.8 times negative sine, bracket open, pi times 0.4 divided by 0.8. And this gives me negative 2 pi, which is negative 6.28318, yada, yada, yada. So this is the precise answer. We were pretty close, even though we did this way, right? It'll always give you an answer that's pretty close. But this one will give you the precise answer. Let's say when you're doing a multiple choice question and this option is not there, then what do? You want to look for the next closest thing, which is negative 2 pi. If you do it this way, if you do it this calculator way. If y is a times sine kx, y prime is k times a times cosine of kx. Sine becomes cosine. You pull out the k. Whereas if a is cosine, the original function is cosine, then that thing becomes negative sine. So this is the shortcut for these guys, for trig functions. It's pretty, that's it. That's all you have to know. Again, keeping track of all these shortcuts is going to be pretty difficult, but eventually if you work with these a lot, and you'll take a course in this in grade 12, you'll see that it's not that difficult. Once you know this, these things become pretty simple. So look at A. They've given us a cosine function. They've given us y. What's y prime? Use the formula there that's on the side. We're doing A. It's a cosine function. It'll become something else.
You bring out the 3.
You bring out the 3. You're going to multiply that with the 6, right? You get an 18.
Mm-hmm.
What does cos become?
Negative sine.
Yeah, so you multiply this with negative sine of 3x, And these constants, like they were with the quadratics or the polynomials, they always disappear. So the answer to A, if you want to find y prime, is negative sine 18 sine 3x. And whatever they want you to find, you just plug that as x. That's it. What about B? What's y prime for B? You have a sign, right? Pull out the 1 over 2.
You get negative 2.5
Yeah, negative 2.5. And what does the sign become?
cosine.
Cosine. That's it, and you're done. And whatever they want you to find the IROC, you plug it in here. So if you know this method, you can probably even do this in your head, because usually the answers are going to revolve around pi's. You don't have to go around doing the plus minus 0.01, but that always works, okay? But this one will give you the more precise answer compared to that one. What's the answer to C?
2 times negative sign.
Negative sign, yeah. 2 times negative sign, which becomes negative 2 sign, and the bracket always stays the same. Whatever you had here will be here, okay?
Mm-hmm.
The bracket always stays the same. So this will be 8x, and that's it. You're done. That makes sense?
Mm-hmm.
Is this difficult?
No.
All you have to do is just have to know the rules. What you do usually is you have a cheat sheet that you're gonna make yourself, or they'll be given to you. Like, for example, let me just Google cheat sheets. Um, mm, like something like this. You see this? This is what we just did.
Mm-hmm.
Once, and product quotient rule is what we did last time. This is the exact same thing that we did last time. If you have a rational function, so as long as you have a cheat sheet, you are good to go. Okay.
Mm-hmm.
It gets a little bit more complicated later down the road, but if you understand what we just did, it's just basically that. And so that's it for trig. If you want to find trig's rate of changes, for average, it's simple. It's just plug and chug. For instantaneous, you're either gonna do plus minus 0.01. That always works for any function, or you're gonna use a shortcut if you know the rules. But the rules are pretty simple. Sine becomes cos, cos becomes negative sine. Let's look at it for another type of function. We just did trig. I'm trying to find mid chapter is not going to do it. Rate of change. We'll do it. Rate of change. There we go. Not going to use that. Not going to use that. Where's the equations? There's no equations, or whatever. We're going to come up with our equations. So here we have some money being invested. It says compounded annually, okay? Is your money gonna grow linearly, or is it gonna grow exponentially?
Exponentially.
So there's two ways our money can grow. One of them is called the simple interest. One of them is called a compound interest. How does simple interest work? Let's say your principal amount during year 0, your principal amount is $100 for both of them. And let's say the rate is 10%. 10%. So after year one, okay, after year one, the interest that you would have earned for simple interest, what's 10% of 100?
It's 10.
It's 10. So you get a $10 interest. So your total amount becomes 110. For compound interest, it's exactly the same. 10% of 100 is still a plus 10. For the first year, your two numbers are going to be exactly the same. For your second year, for a compound interest, that's still going to be a $10 boost. For a third year, it's still going to be a $10 boost. So after second year, your bank balance would be 120. After third year, your bank balance would be 130. That's called a simple interest. But for compound interest, things start getting a little bit dicier after year one. In year two, instead of getting 10% of the original, you get 10% of this number, the amount that you had before. What's 10% of 110?
11.
11. So you get a plus 11. You get your bank balance would be 121. Next year, you're going to get 10% of this. What's 10% of 12 point, okay, I just gave it to you. It's going to be 12.1, right?
Mm-hmm.
Plus 12.1. So it'll be 133.2. See, compound interest starts beating its counterpart after the first year. For the first year, they're both going to be same. But if it says compounded annually, you're looking at like this. If you're looking at a simple interest, then that thing will straight up only be like a linear line. So here they've given us the principal amount is 6,000. The interest rate is 0.075. Part A says determine the equation. This is the formula. Your amount after t years becomes your principal amount, 1 plus the interest rate to the power of t. So here, your final amount will be 6,000 times 1.075, okay, like that, to the power of t. That's the answer to part A. Part B. Find the instantaneous rate of change at 10 years. So what do we do in part B? It's asking us to find the IROC when time is 10. Well, you can always use the calculator method, right?
Mm-hmm.
If you have 10, what are your two numbers? Where are you going from? From what to what?
10.01.
Yeah, to 9.99. So that's all you have to do. So 6,000, this always works. 1.075 to the power of 10.01 minus 6,000 times 1.075 to the power of 9.99 divided by 0.02. The answer is $894.33 per year. So what that means is this function, this is an exponential function, has a y-intercept at 6,000, and it's going to grow exponentially like that. When time is 10, you're trying to find the slope of this tangent line, and we just found that it was 894. What that means is after 10 years, the amount in your bank is growing by $894.33 per year. Okay?
Mm-hmm.
When is it gonna grow the greatest? Before 10 years or after 10 years?
After.
After, exactly. The more time passes by, the more vertical the slope of the tangent will be, okay?
Mm-hmm.
Exponential growth is very powerful. The bigger the x value, the bigger the y value, but more importantly, the bigger the slope as x becomes bigger and bigger and bigger. So that's the answer to part B using the calculator approach, which always works. Now here's the shortcut for this one. There's always a shortcut, right? Why not? If you have f is equals to a times, this is just a b, okay? This is just a b to the power of t. B is the base. In this case, base is 1.075. F prime is going to be the exact same thing. This is for exponentials. It's going to be the exact same thing, except you have to multiply this by the ln of the base. So here, if my a of t is this, what will be a prime of t? Use this formula here. It's going to be the exact same thing, and then you multiply with the ln of the base. So 6,000, whatever you had initially, right? Look at this, A is 6,000, B is 1.075, T is T. Whatever you had is going to come right back, except you multiply this with ln of what number?
1.075.
Yeah, 1. That's it. Ln is the natural logarithm. Log of x is the inverse of 10 to the power of x. So if you have 10 to the power of x, which looks like this, log of x looks like this. Ln is the inverse of e to the power of x. E is the natural number, it's a constant, 2.71 something. It's going to look like this, and this is called ln of x. This is the inverse of e to the power of x. Log of x is the inverse of 10 to the power of x. When you're doing an exponential, when you're trying to find the shortcut for an exponential, you multiply it with the ln. So now let's see, our answer was 894 or something. Now to answer this question, all you have to do is find a prime of 10. So this becomes 6,000 times 1.075 to the power of 10 times ln of 1.075. That's it. You don't have to do the plus minus shenanigans if you know the shortcuts. To the power of 10 times ln of 1.075, and the answer is exactly what we got last time, 894. Cool.
Mm-hmm.
So there's a shortcut for an exponential function. Part C is a little bit different. It says, suppose that the interest rate was compounded semi-annually. What would be the instantaneous rate of change at 10 years? So far we've assumed that it was being compounded annually, which means once a year. Semi-annually means it's going to be compounded every 6 months. So how is that going to change our things? This is what's going to happen. If you're compounding it semi-annually, means twice a year, right?
Mm-hmm.
That means your yearly interest rate is going to be divided by 2. So here, instead of I being 0.075, it'll be 0.075 divided by 2. It'll be 0.0375. But then now the number of compounding periods, last time we were going till 10 years. So from our table here, we would have had year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But because we're doing it every 6 months, our compounding periods would be 0.51, 1.52, or sorry, 1.52, yeah, 2.53, like that, every 6 months. So did the compounding periods increase or did it decrease? Last time we had 1, 2, 3, 4, 5, 6, all the way to 10. We had 10 of them. How many of them do we have now if we're going by 0.5?
20 of them.
20. It doubled, right? It increased. So number of compounding periods, which is this t value, that thing doubles. So you get 2t. So your equation, if you use semi-annually, in this case, would look like you need to add that thing. So our interest rate is now 1.0375, but now our exponent becomes 2, okay? Like that, 2t, if you're compounding it semi-annually. Now, let's use the shortcut for this one. Not a whole lot changes. A prime of t is the exact same thing, okay, like that. What do we multiply this by? Ln of what?
1.0375.
Yeah, 1.0375. But notice now that we added a 2 here, there was nothing being multiplied with a t. So if you add a 2 up there, you need to multiply this entire expression by 2 as well, like that. And this thing is called the chain rule. If you do something elsewhere, if you modify this in any way, you have to modify the latter expression in the same way. So we multiplied t by 2 up there. You need to multiply the entire expression by 2. Now let's find a prime of 10. Now let's see. And usually what happens is the more the number of compounding periods, the higher the interest. So I'm expecting this rate of change to be higher than 894. So now let's plug in 10 in there. So 6,000 times 1.0375 to the power of 20 times 2 times ln of 1.0375. And I get 922. So the prediction was right. The more the number of compounding periods, okay, when you keep everything else the same, if you have more compounding periods, or if you do this is what I mean. If you compound it semi-annually compared to annually, your interest rate will always be higher. This is why if you take a loan from the bank, it's compounded every day. That's why it comes out to be a lot. Cool?
Mm-hmm.
But if you deposit something, then it's compounded every month or every year. That's why, let's say you give the bank $1,000, you're gonna get probably $20 interest in 1 year. But if you take $1,000 from the bank, you're gonna probably give them back $100 back. So the interest that you give back will always be higher than the interest that you get from the bank because of two things. One of them is the interest rate. If you borrow, it's always going to be higher. Okay. If you borrow something, it's always going to be higher. That's the reason number one. Number two is because of the compounding periods as well. If you get, it's going to be annually. Sorry, if you give, it's going to be annually, but if you borrow, it's going to be daily. So you get, yeah, screwed over. So that's the idea behind finding the IROC of an exponential function. F is a times b to the power of t. F prime is the exact same thing, except you multiply this with the ln of the base. And if you multiply this with anything, you're going to multiply the entire expression by that number as well. That makes sense?
Mm-hmm.
Is that all they have? You remember half-life? The amount that you'll have left after t years is equals to the initial amount, or the principal amount, times 1/2 to the time that has passed divided by the substance's half-life. So here, to answer question number A, they've given us the t. What else do we know? We're looking for A of t. What's A0? What's the initial amount? How much of it was there in the very beginning?
100 grams.
100 grams. So that's your A0. And the half-life, it says, is also 5730. This one doesn't require any computations. You add 100 grams, the half-life is 5730 years. The time is 5730 years, the exact same thing as the half-life. What's your final amount? Remember, half-life is the time it takes for it to reduce to half of its weight. Or not weight, sorry, mass. So if you started out with a mass of 100 grams, after your half-life amount,
You
your
get
mass,
50.
yeah, you get 50. That's it. To write an equation, well, the equation will be 100 times 1 over 2 to the power of t over 5730, like that. This is your AT, okay? We're going to find a prime of t. Remember, the idea is exactly the same because this is an exponential function. What will be a prime of t? It's an exponential function, so whatever you had initially, you will get the exact same thing, okay? 100
Mm-hmm.
times 1 over 2 to the power of t over 5730. You multiply this with ln of what?
1 over 2.
1 over 2. But now notice the t. We're dividing it by 5730, right?
Mm-hmm.
So you gotta divide the whole thing by 5730. It's times 1 over 5730. Last time we are multiplying it by 3, so you multiply everything by 3 or 2, whatever it was. Here you're gonna divide everything by 5730. So it says part D, estimate the instantaneous rate of change. So you find a prime of 100. All that means is you just replace this with 100 in this expression, and that will give you the answer. 100 times 0.5 to the power of 100 divided by 5730 times ln of 0.5 divided by 5730. The answer is negative 0.01195 grams per year. And that's the answer to part D. If you want to sketch this, on the x-axis we have time in years. The half-life is 5730. Initially, we started off with 100 grams, right?
Mm-hmm.
After 5730 years, how many grams do we have left?
50.
50. So this is our starting point, and we know after 5730 we'll have 50. That's how it's going to look. And this is an exponential function. The b value is less than 1. That means it's going to be an exponential decay like this. What we just found in part D is at 100 years. So right here, we found the slope of that tangent line right there. Are we expecting that to be positive or negative?
Negative.
Negative, and that's what we got here, negative. Which means that after 100 years, the substance carbon-14 will be decaying at a rate of 0.01195 grams per year, okay? It's a very slow decay.
Mm-hmm.
It's a very slow, and some things like uranium or something have half-lives of millions of years. Carbon is used in something called carbon dating, used in to date organic substances, such as fossils, right?
Mm-hmm.
Fossils, well, that's the only thing that's left, basically, like bones or something. That's how we know about species such as Neanderthals. Have you heard about them?
Yeah.
People that came before Homo sapiens. So this is used to date stuff maybe like 40, 50,000 years because its half-life isn't that high. But if you want to date something that's old, super old, then you need to use bigger elements. Carbon-14 isn't gonna cut it. So you usually use isotopes of uranium or something. All right, whatever. Let's call it a day there for today.
Okay. Thank you.
So yeah.